Welcome to Embedded. I am Alicia White alongside Christopher White. Our guest this week is Jess Frazelle, and we're going to talk about computers, maybe Rust, and computers.
Hi, Jesse. Thanks for putting up with the technical difficulties.
Thanks for having me. I'm excited to be here.
Could you tell us about yourself?
Yeah. So I've been a computer nerd for a long time. I've worked on a lot of different projects, whether it's like the Go programming language, Docker, and now most recently we started a computer company.
And that's Oxide?
Yes, Oxide Computer Company.
What do you make? I mean, you must make computers because you introduced it as a computer company, but I think not laptops.
Yeah, I mean, I would love to one day do that, but right now we're making rack scale servers. So not even individual servers we're making. We're actually selling racks of servers themselves. So you get a bunch of servers all already packaged into a rack.
Okay, we're going to talk about why that's interesting in a few minutes. But first, I want to do lightning round. We'll ask you short questions. We want short answers. Are you ready?
Yes.
How much malt powder is required to change a milkshake into a malt?
Okay, so I mean, this is a contentious question, especially for me. You must have gotten this question from someone internal at Oxide because I have an obsession with malt powder. I like double what most normal people want. So, I mean, that might be like 8 scoops or something ridiculous.
Do you have a favorite vintage computer?
Oh, that's hard. I really like the old Macs because they're fun to play with and they have some of my favorite games just from my own past history. But I also love like the 486 they have has a bunch of like old software that like my grandpa wrote. So there's like a sentimental aspect there.
When you say old Macs, do you mean Apple IIe or iFruits?
Wait, stop. Apple IIs were not Macs.
Yeah, this is like the Macintosh SE.
You can't say that.
Yeah.
I'm sorry. I'm so ignorant.
Favorite processor?
Ooh, so currently it's the AMDs because they're just like the most powerful that's on the market today. I mean, ARM has like a lot of promise, but it's just not there yet from what I've seen. Yeah, it's hard. I also love RISC-V as far as like instruction sets go because it's open source. And I think that there's like a huge amount of potential there when it comes to like what the future will look like in like 20 years or something as to what people are running.
What's your least favorite programming language?
Like, I really like all of them. I would say any language that is not compiled because, I mean, I love to, program by compile time errors, which sounds terrible, but like I like to refactor a lot. And the easiest way to catch mistakes is that way. Yeah, any language like JavaScript now with TypeScript is great because like you can kind of get like those typed errors. But I don't think I have a least favorite one, honestly.
It sounds like your least favorite might be Python.
Yeah, I mean, I do love Python on occasion, though. I mean, it depends. But yeah, Python is hard to refactor well.
Would you rather be a superhero or a supervillainous?
Yeah. So, I mean, I like 95% superhero, but then on the occasion when you need to like really get something done, maybe that like 5% of supervillain comes out. I don't know.
Do you have a favorite fictional robot?
Yeah. So I have a couple. I love Wall-E. Like he just like touches my heart in a place. And Betamax from Big Hero 6 because he's like this caregiver and then they kind of turn him evil, but then he goes back to being like the nice guy again, which is cute.
Okay. On the website, it says you make hyperscaler infrastructure. How is that related to large racks of computers? Yeah,
so basically what hyperscalers like Facebook, Microsoft, Google, all of those huge companies did is they were pretty much sick of using like any proprietary vendors' hardware for their computers, because like mostly what you're doing is just like stacking a bunch of boxes on top of each other, and it kind of makes no sense when you're running at like this super large scale, because like on those boards you get a lot of things that like you don't need in a data center. Like you don't need like a mouse, you don't need like VGA, you don't need a lot of things. So they kind of redesigned everything, getting rid of all of the old like existent desktop components of this hardware, and then they wrote all the software on top of it. So what you get is actually like way more dense racks. So you can pack a lot of compute in there. And you also own the entire stack. So when it comes to like bugs, no longer are like these vendors that you're kind of like slap sticking together to build like this data center. They aren't like pointing fingers at each other. Like, sure, you have like, a CPU vendor and vendors for like storage and stuff like that, but you get rid of a lot of the like stuff on top, like software vendors and stuff like that, because they wrote all of the stack. So you get like this really nice way to deploy. It like speeds up productivity, and you get a lot more compute for the like power that you're using, and it really just cleaned things up throughout. So we're basically doing that for like everyone else, everyone who like doesn't have a team to build out like a whole hardware infrastructure for their business, because it's like not what they do as a business. So we allow like all the rest of like Fortune 500 companies or whatever to have what these hyperscalers have internally without all the work.
Okay, I'm going to go back to the word hyperscaler. I didn't realize that meant just the big companies, the companies that are big enough to do this sort of thing.
Yeah, I mean, I think that it means more than that. It also means like the companies who run at this massive scale, but it is like even companies that run at massive scales, they don't necessarily have the skill set or the right people internally to do it.
It totally makes sense. I mean, this seems like something, if you're not a software company, that you should just buy. I mean, this is something that is kind of boring. It's almost a commodity.
You're not a software company or not a hardware
Totally.
company?
I meant not a software company. Not a hardware company too. I mean, you'd have to become a hardware company partially to do this, but it's the Facebook, Google, as Jesse mentioned. Okay, so the reason they do it is because it is more cost effective for them in the end.
Yeah.
How come big companies aren't doing this? Dell or Apple or any of the computer manufacturers?
So they're trying. Like you can get a set of Dell boxes with like VMware on top, and like they're kind of trying to make this thing that is like all put together, but like it's two different companies within Dell. So you really aren't getting like this really integrated software and hardware experience. And also like you aren't getting on top like really a modern interface and API for deploying. There's a lot of just, like old thoughts there. But yeah, like it's very different than what you would see inside an actual hyperscaler, and it's different, definitely different than what we're doing, because it is still the old hardware at the bottom. Like you still have all the desktop stuff that you don't need in a data center, which makes no sense. So like we're definitely getting rid of all of that. Like we even went so far as to like not even have a BMC on the servers. We have like a very traditional service processor instead, so that the BMC like has less control now. Like, I mean, the BMC should have never had so much privilege in the first place, but people just kept adding features there because it was where they needed to add features. But now, like, we've taken out a lot of that, like, stuff that doesn't need to be there, and actually the BMC just does what the BMC should do. The service processor in our case, and that's like boot the machine.
What does BMC stand for?
Baseboard Management Controller.
Okay.
So what do these look like architecturally from the hardware standpoint? So I worked on rack scale routers a long time ago, and it was one thing. It had a central control processor plane, and it had a bunch of line cards and things, but it was one unit. when I think about data centers, I think of a rack full of individual blade servers. Is this a rack full of custom designed individual blade servers, or is it a rack full of one kind of purpose-built thing?
Yeah, so it's a bunch of like what we're calling sleds,
Okay.
because they're more the like open compute project form factor where like, so in a rack, you have like the width of the rack. So each sled is actually half the width of the rack. And then it's like 1 OU or 2 OU like height. These are the open like units in the open compute project. That's how they're defined. But yeah, so we have just a bunch of those sleds in there. And that's what makes up the rack.
When I worked at HP in their net server division 9 million years ago, we had monitors to make sure that the server was doing what it should. Does each rack have a monitor?
Yeah, so each rack has like rack controllers, which internally does all the software for like distributing compute and like managing like networking for the rack. Like it does all the kind of like smart things in between. I mean, we have also a top of rack switch, which might be in the middle of the rack. It might be a middle of a rack switch. We have 2 of those for making sure if one goes down, we have another. Yeah, so these rack controllers, if you have multiple racks, all of them are going to talk together. And then in this kind of like one pane of glass, you have this user interface where you can see all the racks at a given point of time, and then everything that's going on. And you can drill into individual racks and then see like, oh, like this rack, this disk needs to be replaced, or just anything like the latency on this like network cable is bad. You can drill into any like finite amount of detail.
Do you still use SNMP?
That I do not know.
It's a very old protocol, although it is still in use, that describes the health of units, monitoring like that. And I just wondered what the latest technology, I mean, what is this view built upon?
So this is going to be built on all of our software that we're writing even from the firmware up. So I think that largely we won't use something like that, but I actually have no idea. I'd have to ask one of our engineers.
Fair enough. How did you decide that this was a good idea? How did you say this was a space that was worth doing?
So I think that like between the 3 of us, like me, Brian, and Steve, like we all had a different process for going about this, but mine was mostly talking to people who were already running on premises. And I talked to like a bunch of different people, just like cold reached out to people too, who like I knew that they had to have like some sort of on-premises like existing hardware. And then I wanted to see like what problems they had. And because I wanted to make sure like we were actually solving a problem for people. And it turns out like it's a huge problem for people running on premises. Like there's problems all over the stack. Like it could be in the firmware where you have like a huge outage and then you get like 2 vendors basically pointing fingers at each other, and your bug doesn't actually get fixed. Like your business is actually on the line because like these 2 vendors are pointing their fingers at each other, or it's bugs higher up in the stack because you have like some software layer on top that was then talking to the hardware, and then those layers got basically pointing fingers at each other. So almost by removing all this like by putting this together as like almost one unit, then you remove a lot of that, like we don't know what's happening between these 2 layers. Also, by open sourcing a lot of it, you get visibility into the layers of the stack as well. And a lot of these like the folks that I talk to, they don't have like on premises necessarily like nice APIs that you would get in a cloud. Like it's not like an EC2. It's not like GCP where you're deploying VMs. Like it's not kind of the same API, like very developer friendly experience. So it seemed like there was a lot that we could do there as well.
And so now they can just point the finger at you.
Yeah, which is fine. I'm fine with having a finger pointed at me.
Open source. How much of what you're doing is open source?
Yeah, anything that we are writing software wise is going to be open source. Even like we're going to open source the hardware as well. But we're definitely going to open all of it. The things that might not be open source because of vendors where we're wrapping, like, say, AMD's, proprietary firmware for their silicon, that we can't open source that. But we're working with a lot of vendors to get these down to like the lowest bits, so that we open source as much as possible.
Do you have anything open sourced already, or is it all future?
Yeah, there's a few things on our GitHub. It's github.com/Oxide Computer. I think there's just a few things with regard to like the API, but yeah, we're just open sourcing random stuff as we go.
You talked about open compute. That's where Microsoft, Google, Facebook got together and said, we want our computers to look like this so that we stop having to deal with all you people. We just want them to be the same. Is that?
Yeah.
Okay. Why are you doing that? I mean, of course, if you do eventually want to sell into the bigger data centers, the hyperscalers, you would need to conform to that. But if you're not selling to them, why not do your own? So,
yeah, no, it's super true. And that's a really good point. What we actually are doing is a little bit different than what they're doing, because so there's the Open Compute project, and then there's this other one called Open 19. And Open 19 was like LinkedIn kind of took their design for hardware and put it into a different foundation, basically. But there's good parts of both. So like Open 19, you get this really nice cabling on the back of the rack for networking, and you can just basically like pop it right into the network slot versus having individual cables that you have to unplug. So we're going to take that, and then we're also going to take the power bus bar from the Open Compute project. We're basically taking the best parts of both and putting them together, which is not what people in the Open Compute project typically do.
And I don't want to ask how much is a rack, because that seems odd. But if I wanted to make a CPU, or if I wanted to make my own chip, I know that I shouldn't even consider it if I don't have $2 million.
Two.
Well, that's a small chip. What scale of business are you looking for?
Yeah, we're looking for pretty large scale businesses. Like, sadly, this won't be the type of server that's just running in someone's garage. I mean, unless they have the money to do so, that would be really fun. I mean, I would love that. But yeah, we're really targeting like Fortune 500 companies, large enterprises.
Cool.
Speaking of running it in your garage, so if I wanted one, what kind of power would I have to install in my house?
Yeah, so here is where things get interesting. Because a lot of like enterprises and traditional companies, they either are running them in their own data centers, or they're running them in colos. It's a little bit different than like hyperscalers kind of can draw as much power as they want to. Like, they get up to like a huge amount of power on the draw. But like for us, it was actually hard because like we need to like conform to basically all these colos where like getting 16 like watts or whatever, it's the maximum that you can get. Whereas like a hyperscaler, you would go well above that. So we had that as a restraint. And so some of these racks might not be fully populated based on the power that people can draw from them. But then we can also start filling it in as they like realize how much power they're actually drawing. So like, say, start with like half a rack, and then like we'll give them servers once they realize that they can handle the capacity for that.
I seem to recall the telcos used to want DC power, huge high amperage DC power. Is that still the case? Or
we haven't actually talked to that many telcos,
okay,
so I'm not sure.
Stay away from them.
I mean, that's been true for some data centers as well, that they want DC power, big DC power, lots of DC power. Which actually brings me to, you recently wrote an article about data centers and carbon footprints. Could you summarize?
Yeah, so I started out looking up, well, actually, okay, so it started as one of our hardware engineers, he wrote this like really nice thing internally for like how power works. And then I got like kind of nerd sniped by it. And I was like, whoa, like this is like really interesting. And I didn't know like anything, honestly, before writing this article. And I like super dug into it because I was like super interested in where basically we could help people on their carbon footprint, because it seems like there's a lot that we could do to get like the power usage better. And so I looked into like what all the hyperscalers basically are doing about their carbon footprints, and like how they're looking at that. And then I really dug into like just how this works in general, like what power usage efficiency is, and how each hyperscaler does power, because actually Microsoft has a different way of doing it than like Google and Facebook, which is interesting.
In this week of ash raining over the San Francisco Bay Area and lightning storms predicted for more fires, why does carbon footprint matter?
Yeah, so it super matters. Like sadly, like the ash is due to like a natural disaster of the fires. But like with data centers, like that's us. Like we are the enemy there. Like we're the ones that causing it. So if there's any way that we can make it more neutral, then it's like a huge deal.
So what are some of the things that are different between the different hyperscalers?
Yeah, so Microsoft didn't go the route of using a power bus bar, which is like just this huge like metal thing on the back of the rack that serves power. They actually do individual cables. And when I first like started looking into this, I was very naive, but I was like, whoa, like I wonder if like, you know, by making this decision, like Microsoft is actually like causing, you know, them to use a lot more power where they don't need to. And it actually turns out it's pretty negligible. There's a lot of nuance here when it comes to like the right thing for the job, but like as long as you have cables that are very, very, very high quality, which I assume they do, then you're getting the same power draw as with a power bus bar. And I don't know exactly why they did it that way. There's a couple
that's how
talks
they did
on
it the first time that way, and it worked.
Yeah, it's true. There's a couple talks on it, but you don't get the like serviceability gains that you get from having the bus bar, because like when you have to service one of these things, you have to like go unplug the cable. Whereas like with the bus bar, you just like pop the server in and out from it. There's no cable. It's like super nice.
And in the article, you said that Google sets its data centers at 80 degrees Fahrenheit, 20 C, instead of the usual 70 F, 21 C. What? I mean, does that matter that much?
So it depends. I've been looking into this, and I would actually be curious, honestly, Google's take on this, because it seems like there's a few articles that say the original studies, which say like you should get to a max of like 77 degrees before your hardware starts like it's damaging to the hardware. Those studies are pretty old, so like a lot of people are like, you know, Google doing this, maybe it's not that damaging. But I would actually be interested in Google's take on it, because since they've been the ones doing this for the longest amount of time, they would probably have the best take. But it does seem like the industry is more coming towards, you know, maybe we should retake a look at like how CPUs get damaged in heat or something like that. There's like a opportunity for improvement.
That's a huge part of the whole power draw too, because if folks haven't been in a data center, the ones I've been in are, you have to put earplugs in before you go in, because the sound of the air conditioners and the fans and the racks are so loud that it's damaging to human hearing. It's just so much cooling going on. It must draw just a huge portion of the total power.
Totally.
So power usage efficiency, PUE, does that measure the cooling? Does that measure the processing? What is that? How is it measured?
So that's the total energy required to power. And that includes like lights, cooling, anything that's like within the building and drawing power. And then that's divided by the energy used for servers.
Okay, so that's the overhead. It measures the overhead versus what the server is doing. But is the server doing computing, or is it doing monitoring, or is it just sitting there doing nothing and drawing power for no reason?
I mean, it depends, actually. Like, PUE is actually like this actual point of contention, because when I started asking people for feedback on this article, it was funny because a lot of them were like, you can't really take PUE seriously. Like, especially like numbers people give out. A lot of people who give out their PUE numbers, they might not be taking into even like environment from the outside, especially if like a data center is located in a hot and humid place. Like there's a bunch of stuff that isn't included. So like the workloads being used, definitely like not included.
Okay. So PUE doesn't measure everything and may be a confusing measure.
Yeah. I mean, it can be done well and it can be done poorly, basically. People don't give a lot of information as to like what exactly they put into their PUE numbers, but if they're transparent about it, then it's way better.
Sounds like all benchmarks.
Yeah.
This article was posted in ACM Queue. What is that?
Oh yeah, so Q is this magazine put out by ACM, and it's more oriented towards practitioners. So like IEEE has Spectrum, which like I absolutely love. It is super nerdy. Like they talk about like robots and like all this crazy stuff like drones. But Q is more oriented towards like what people like engineers actually do day to day in their jobs, and problems they encounter, and it's more oriented towards practitioners than academics. Yeah,
that's useful. Is it mostly computer stuff, or is it more mathematics?
There are a lot of mathematic articles. It depends on who writes them, honestly. So mine are typically like I just dive into something random. There's another one that's more like an Ask Alice or whatever, but you're like getting software help from one of the authors, which is hilarious because he's very blunt. It's a mix.
You also have a podcast.
Yes.
Tell me about it.
Our podcast is pretty cool. We started it before we started the company. So then we like had a series of episodes that we could release. And it was mostly people who we had talked to like before starting the company that we had learned things from, and that had like interesting stories about things between the software and hardware interface. It's mostly stories. There is a romantic aspect of it. Some episodes are more romantic than the other. We like to talk about old computers, people's love of computing.
And you wrapped up a season in February, but it's August. When is the next season coming?
Yeah, so this is sad. We love recording in person, and like with the pandemic, it's been really hard to do that. We do have like we have a few episodes that are already recorded. Then we had a bunch of people who we had lined up to be on it, and then things kind of got derailed. So we're hoping to like get started again soon, but we'll see. Yeah.
You claim it's the nerdiest podcast on the planet.
Yeah. I feel like I've learned a lot from the podcast. It's funny because I'll still listen to episodes, and in doing show notes, like I even learned stuff from going back and doing the show notes. It's hard actually. When recording the podcast, I've found that I miss a lot of things just because I'm like trying to keep the conversation going or trying to catch it all. And then like on the re-listens, I get a lot more out of it. So I don't know. I think it's like the thing that keeps on giving.
That seems very familiar.
Yes, yeah. It does. What made you start a podcast?
We thought it would be fun and a way to like, break up just like working day to day, and a way to just like get folks' opinions and their own experiences from working on hardware. I mean, I think what I love about it is that a lot of folks that we saw during our raise and stuff, like a lot of people think that like this like lower level programming and lower level engineering and like really hard tech, like that it's like a dying breed. Like people don't like really see it anymore because there's so many SaaS companies. It's like, actually, no, like it exists. And so like, this is our way of being like, hello, there's people down here. Like everyone has stuff down here, and it's like a huge thing. And we're trying to kind of like unravel that at the same time.
You mostly do talk about computers as opposed to embedded devices. Is that right?
Yeah. Yeah, there's not much embedded. We could venture in that area. It's definitely on topic. I think that we didn't include that, just like we didn't purposefully not include that. It was just more like it just happened.
Oh yeah, I mean, you haven't done that many, so you
Totally.
still have a lot of things you can explore before you get to origami, glass blowing, and all of the other things we have kind of.
To be fair, so we started on some of those early. So.
That's true.
Do you have any? I don't like asking people for their favorite episodes, but if somebody wanted to check out the podcast, would you recommend start with this one?
So I guess one of my funniest stories would be we had Jonathan Blow on the podcast, and he wrote the Witness, like the video game, and I played that game. I was super stoked for him to come on it because I played the game, but I didn't want to make it weird. So because I can make it really weird really easily. And so I was like, okay, don't be like this weird fangirl. But so I had all these questions for him about these videos that are embedded into the game, and I didn't ask any of them. And then basically he left, and then we're going back over it, and I was like, okay, but I was trying to explain to Brian and Steve these videos that are embedded into the game, they drove me nuts for days. I was trying to figure out the meaning and all this stuff, and I mean, I'm a crazy person when it comes to video games, and I finish them in 2 days and won't shower, won't eat, I just have to get it done. And so this was all the crazy that I was trying to hide from him, and Brian and Steve are just oh my god, I don't even know what to do with all this information that you're giving us. But so in the recap episode, I basically go over all of this. And then I was just hoping that Jonathan Blow would listen to it and be like, what the hell was going on in that girl's brain during this episode? But I don't think he did.
Do you have a lot of interaction with listeners?
What do you mean? I
mean, do they email you and tell you you're wrong like ours do?
Oh, so yeah, no, we've had a few of those, and they're pretty funny, honestly. I mostly forward them to Brian. But yeah, no, we get a lot of, and it comes in over our catch-all email address, which, I mean, we get a lot of fun stuff in there.
And it's nice to get the complimentary emails, although they don't stick as long in my head as some of the others.
Totally.
I want to go to some of our listener questions. One of which is your coworker, Rick Arthur.
That doesn't seem right.
No, it really doesn't, does it? Why open source firmware?
Yeah.
Wait a minute. Let's actually go back to just firmware. When I say firmware, it's what's running on my processor. It's not really software because it doesn't really interface with people. And it's not hardware because it's typey C++. But when you say firmware, you mean something else, don't you?
So, no, I think that we have the same thoughts there. I mean, we also are going to have firmware running on a bunch of microcontrollers and stuff like that. I think it's basically the same definition.
Okay. I thought it was the BIOS part.
Oh yeah, no, we definitely have that. I would consider the BIOS what runs on the CPU. No, or is that not?
You would consider the BIOS firmware?
Yeah.
It was when I worked on servers a second time for Park, and they were calling it firmware. And I was like, what do you mean? This isn't firmware. This is a giant chip. You don't run firmware on this sort of thing. But yes, it was where I encountered BIOS as firmware. That has long been one of those things that nobody wants to give you. It's very expensive to get BIOS code if you want to be able to modify it. But now you're going to open source it?
Yeah, I mean, mostly this comes from, when I was talking to a bunch of people about their pain with running on premises, a ton comes from the firmware, and it comes from the lack of visibility there. It's you don't know when things go wrong, why they're going wrong, which drives me nuts. And you get the vendors pointing their fingers at each other, and then you also talk to members of this team, and then you get routed to a bajillion different teams, and it just seems like no one knows how this thing actually works, which is nuts. And by making it open source, one, when we fix bugs, it's very visible, where the bug was, where it came from. That just helps me personally sleep at night, because I actually know oh, that thing got fixed. Like, look at those lines of code that changed or whatever. And then you actually know what the bug actually was, which you can never get a straight answer from a vendor on. And then also when it comes to like security, these like, a bunch of the stuff running in the lower levels of the stack, like all of this has like way too many privileges. Like they have full power basically over the computer. And it's also the code that we know the least about, which is super messed up. And so you get a bunch of vulnerabilities. We saw this with like Rick found the vulnerability in the VMCs. I mean, there's just a bunch of vulnerabilities there. The Bloomberg kind of like huge expose where they thought that like the supply chain had been modified. Like that was interesting, but also like why even go through the supply chain when you could just walk through the firmware, because like there's so much in there. Intel has like huge web servers in there that no one knew about for a long time. And it's just like all this stuff just needs to be opened up so that we have more eyes on it. There can be more audits and people can know what's actually happening in their computers.
It seems like people don't even know what's in there. Despite not even how does it work, but oh look, there's a little port you can connect to and mess with Intel's firmware. You know, it's like, why is this here?
It's a mystery, yeah.
Well, to be fair, and having seen some of this code, it's built on layers. I mean, it's huge layers of layers of layers because they have to support a whole bunch of different interfaces. And I mean, all the mice, all the keyboards, all the processors running this speed and monitoring for this exception and that exception. And it started out one code base 25 years ago, and that code is still running.
Yeah. And that's like also why we have this opportunity to clean it up, is that like we don't need all those drivers for mice. We don't need all the drivers for keyboards. Our customers will never actually interact with the firmware because like it makes sense, honestly, why like the BMC even got so packed with a lot of code. It's because like when that's all you expose to people, that's where you have to put features. But most features shouldn't have that level of privilege. And so we actually get a chance to clean it up.
So the level of privilege, it seems like the firmware does need a high level because it needs to wake everything up. It needs to be able to talk to the internet. Well, I don't know if it needs to talk to the internet. That's different. But it needs to talk to the memory and the CPU and the hard drive. What privileges are you taking away?
So it's still going to be very, very privileged. What we're taking away is like these feature sets where, you know, it does have to talk over the internet, or it does have to like interface with a bajillion different keyboards and mice and all this like all these vendors for various things. Like we don't need all that. We only have certain vendors that we're working with and stuff like that. So we don't have to have like crazy interfaces for doing whatever we need. Like actually all we need to do is boot and like interact with what's on the board.
Yeah, sometimes starting over is easier than maintaining.
Oh, it's the basis for a million startups.
You do a lot of automation in your work at Oxide. What kind of automation do you do?
Yeah, so I love automating things. I mean, I do this at home too. I'll automate anything that can be automated. So for the company, like we're still super small, but I with adding every single person that we hired, I was like, okay, like this can be automated. Like adding people to G Suite can be automated. Adding people to a Zoom account can be automated. Adding people to Airtable, like all the kind of like internal tools that we use, the accounts all get set up automatically. I have a bunch of scripts that make short URLs because having worked at Google, I love the like go/thing, and you just like go to this like page and like it's very nice and it's an easier way to remember things. And we have this RFD process, request for discussion, internally, and now we have over 100 requests for discussion. So it's hard to like actually link out to these things because they live out on different Git branches. So I made short URLs for those. So you can just like go to like 100.rfd.oxide.computer and you get routed to the right branch. Stuff like that, where it's just it makes everything a lot easier. And then I automate between like a lot of these tools. So like Airtable to GitHub or whatever, like just weird statistics and monitoring and stuff like that. So it's a lot of random stuff, but it was fun to build because now kind of I joke that like the role of CIO or like chief infrastructure officer is it's a robot.
Your title is chief product officer. What does that mean?
So I think it means a different thing, different places. But for me, it means like talking to people who have problems with their current infrastructure or talking to people that don't have problems, but just have interesting experiences in infrastructure that we can learn from. And then taking that back and kind of like putting all the conversations together into like how we want to build our product to make it better than everything else and make people's lives easier.
Okay. You write some of these tools in Rust. Is that right?
Yeah, I wrote a lot of them in Go at first because it was just what I was fluent in. But as a company, like we're really like writing everything in Rust because it's great for embedded and it's great at a lot of things. And so I was like, okay, like I have to just like knock this off. I gotta just like do it in Rust, which Rust isn't like it didn't start out as being great for like REST APIs, which is what a lot of this is. It's just interactions between REST APIs, but it's actually like super getting there. But I ran into a lot of pain points there, but now it's a lot better. Like with async await is like way better. But yeah, no, it was a fun exercise to write it in Rust. We open source a lot of the libraries. They're on our GitHub page as well. But they were mostly like, they're all purpose built. So like, it's not the entire API. It's just like the parts of the API that I needed. And yeah, it was a fun exercise. I now am, I would say maybe still a little bit more fluent in Go because I find myself writing Rust like it's Go, but I'm getting there. We have some really good Rust folks on the team and getting their feedback on code is great.
Why would I choose Rust over Go? I mean, would you have if it wasn't that the rest of the team was Rust centric?
Yeah, so when I changed like the code for the bots from Go to Rust, I mean, even the Rust folks on our team were like, why did you do that? Like, I mean, Go is actually better for what I was trying to do with like, you know, concurrency of pushing things out to various APIs. I did it mostly as a learning experience. Where you actually want Rust is like memory management, stuff like that. Actually, for Docker, I think that like had Rust been a thing at the time and had it been at the place where it is today, like I think that it would have been a better language for the job because we got into a lot of problems when it came to like embedding C and Go, which is like, I mean, it's hard. I mean, there's really load bearing parts of the Docker code base, which is now in Run C, where like it's all C and very few people actually know what's happening. And so with Rust, you can avoid that because you can actually get the level of granularity that you need.
I see a lot of people seem interested in Rust for deeply embedded stuff and for even micros, but it seems almost more suited to this kind of thing like we were talking about with Docker. Like, shouldn't have been doing stuff in C probably for a utility of that level, right?
Yeah, no, like it would have been great to have Rust then. And I think Rust is like perfect for firmware and what we're using it for.
Firmware being your firmware or firmware being microcontrollers?
Both. Like we're using it for microcontroller kernels, stuff like that. Yeah, we're using it for everything, honestly. The control plane for deploying VMs is going to be in Rust.
Did you choose Rust before the name of your company?
Yeah, Brian wanted to use Rust for sure before that. So the name is very much so a hat tip to Rust as well.
Could have been any Oxide, though.
No, it has a lot of, like, it has ties back into computers. It has ties back into a lot of things. So it's almost perfect.
Well, except Rust, the language, was named after rust, the fungus pathogen, not
what?
Oh,
Oxidation.
that's interesting. I didn't know that.
If you're going to bash a language as much as I do, you got to learn as much as you can about it. That's not true. I don't bash Rust that much. I don't know when or why I would choose it over something I know very well. You chose it because Steve chose it and he cared about it enough to build your company around it. But I don't know.
Well, it depends on what you're trying to accomplish, right? If you're finding limitations in C, if you're finding a lot of that the memory safety and things are becoming an issue. I mean, I don't know. By that logic, why did anybody switch from fourth in the 70s?
Yeah,
It was Pascal to C.
Yeah.
Writing safe C, it's a very rare talent to find anymore. So Rust allows you to kind of do that in a better way.
Let's see. I have questions from Philip Johnston about what lessons can all firmware developers learn from your investigations of proprietary and open source BMC firmware?
Yeah, I mean, there's a lot there. OpenBMC, you have to give them a lot of props because they were really the thing that like started the whole kind of open source firmware ecosystem, from what I can tell. Like they were really like the first open source firmware out there. And so with a lot of like open source projects, what it becomes is like largely an interface for dealing with a lot of like kind of sub modules. Like it has to deal with a lot of like proprietary things. So like OpenBMC became this like basically like communicator over the system D bus of various like kind of sub modules that interact with various vendors' things. And so for ours, like we don't necessarily need all of that because like we know exactly what vendors we're working with. We wanted the BMC to have a lot less features. We just wanted it to actually just do like what a BMC or a traditional service processor, which is what we're calling it, does, which is boot the machine and then interact with a few things on the board. So we kind of took out a lot of the complexity, but like OpenBMC is great when it comes to like being able to work with a large variety of vendor components.
Philip also asked, what are the low-hanging fruit for security and secure boot that most teams miss out on?
Yeah, so I mean, a lot of the vendors have like their own kind of secure boot built into their products. So like Intel has their own, AMD has their own, ARM has their own. And like what we're actually doing is very much in line with Apple has T2, which is their hardware root of trust, and Google has Titan, and Amazon has their own thing as well. We're doing our own root of trust. And it seems like a lot of kind of the big companies, they don't wind up using a lot of those like features from the vendors. I mean, they're mostly all proprietary. It's hard to get visibility into what it's actually doing. So by doing our own and open sourcing it, then we have a really like firm level of attestation going on in the machine, which is really, really nice. So, I mean, I think like what I would love if like maybe, there were ways that either the vendors could like open source their things so that people knew how they worked, or maybe just like not waste time on stuff like that. But I could see why people want it. But it seems like if you're really serious about like writing secure software, you likely aren't using the proprietary vendors feature.
There's a lot of benefit from starting over. I think you're seeing a lot of that. Do you worry if you succeed and make it and you're still building these in 5 or 10 years, you're going to look back and say, why are we still supporting that?
Yeah, I mean, that's like these machines stay around forever. I mean, if we are successful, there is an analog, and like Brian's gonna laugh because I actually am using this as an analog, but the AS400, those machines have been around forever. Like my mom was actually a recruiter for people to work on the AS400, and like just the fact that like they're still around and you still need people to work on the AS400 goes to show how long these machines survive out in the wild. So like we're gonna have ways to easily update our software on the machines, but like this hardware, if we're successful, will be around for a really long time, and we're going to have to support it for a really long time. And I think there are ways to make it easier and make it easier on us, and also ways to make it easier on potential customers, because like if they turn on, say, automatic updates and everything goes swimmingly, then they will always have like the latest software, and it won't be like an Android where like, a lot of the Android ecosystem is still on the like oldest version of Android. Whereas with an iPhone, everyone basically runs the new software. Like we're trying to go towards that model, I would say. But yeah, I mean, we're going to have to support it for forever, honestly. I mean, even Windows in their kernel, like they have like this custom code for like SimCity.
Oh, no.
So we're probably going to have stuff like that. Like, I mean, not SimCity as an example, but the things that stay around forever. We're eventually going to become the thing that we hated in the first place, I'm sure.
But think of the size of the city you could have in your server.
Yeah.
Actually, are you planning ahead for that sort of thing? It's hard because most of the code ends up being corner cases, things that don't quite work together, timings that work on some series of chips and not others. But how are you going to avoid that? Or are you just accepting that that's a problem for after you're successful?
Yeah, I mean, edge cases, I think there's no way to avoid that. But I do think by getting people to actually update their software and having automatic updates and trying to make that the default is a way to make sure, one, that like people get the best experience that they can get, because like we're fixing a lot of bugs at the same time, but also then like we can get rid of things that don't need to be there.
Christopher, how do you feel about automated software updates right now?
Terrible.
Well, it wasn't automated. I allowed it to go.
If we sound different, it's because logic updated.
It shouldn't sound any different. But
yeah, I mean, that's the thing with automatic updates is like, you have to have this level of trust where people trust that bad things won't happen. And that comes from like not messing it up consistently, which is hard. Like it is very hard to get that right.
Yeah, and it's really hard with things that are mission critical, right? There's probably a lot of reluctance within the customer base to that kind of thing still. It's like, wait, totally. I want to decide when to do this and whether it's safe. I want to see the other companies have run this patch for 6 months before I apply it. That kind of thing.
Totally.
How do you battle against that IT managers who are reluctant?
I mean, it's hard, honestly, because like the hyperscalers can do it because, I mean, it's their internal team updating. And like, we do want to give that functionality to people where it's like, oh, like you can automatically update, jobs migrate to different servers, those servers get updated, and then you do like a slow rollout. And I think like, honestly, the ways to battle that are just like transparency, being fully open about how this works, and having hopefully like the first set of like potential customers that we get be very open-minded. And as long as we can nail it consistently, then we don't become like this Windows update just broke my whole thing and now I've been like scarred for life. You want to avoid that. And like we tried to do that with Docker on the upgrades, and I would say it was not great in the beginning, but then you eventually get to a place where it's better and better and better and better. And I think it's just time.
Would you use Dockers on Windows now?
Me?
Yeah.
I actually have, because I mean,
I've gotten burned enough times that I just say no to Docker, but unless it's in Linux. So I just wondered, as somebody who probably has a lot more experience with it than I do.
It's all right on Windows. To be honest, it's not the same thing, because like on Windows, you're getting a VM and you're not getting a container, which like what's nice about containers is like you can actually like share things. Like you can share the network, you can share like various file paths. You can share like the PID, like you can share like your process space with the container, which you can't do that on Windows. You can share files on Windows, which is fine. Network, I actually don't know if you can do that, but it's a different experience. You can't share the process list. I mean, it's like they're actually VMs. At the end of the day, they're slower. They got it pretty fast. Like actually, it's pretty comparable now. But it is just a different thing. It is cool, and it's cool that like Windows IT people are now like coming into this like container space and getting like super more modern and like updated, and that's like super awesome. They're having like easier ways to deploy, but it's also Windows running in a container. So like Linux, you can automate a bunch of things very easily and like get things up and running easily and just get like a process started. But on Windows, that's a whole different experience.
Jess, it's been really good to talk to you. I need to go buy some turnips from Daisy May. Do you have any thoughts you'd like to leave us with?
I would say we're hiring if anybody is interested in joining, but also like we're gonna hopefully have another season of the podcast out. I hope that like people actually learn something from this, and if I got anything wrong, please feel free to email our catch-all email address and I will actually read it.
And what are you hiring for?
We're hiring for hardware or software systems engineers, anything in that mix.
Cool.
Remote or local to?
Most of us are remote now. So yeah, we're open.
Cool. Our guest has been Jess Frazelle, co-founder and chief product officer at Oxide Computing.
Thanks, Jesse.
Thank you. Thank you for having me.
Thank you to Christopher for producing and co-hosting. Thank you to Philip Johnston for recommending Jesse. And thank you for listening. You can always contact us at show@embedded.fm or hit the contact link on embedded.fm. We are still doing transcripts. Soon they will be open to all of you. For now, they're only open for Patreon supporters. But a quote to leave you with from Vladimir Nabokov from Lolita. And the rest is rust and stardust. Embedded is an independently produced radio show that focuses on the many aspects of engineering. It is a production of Logical Elegance, an embedded software consulting company in California. If there are advertisements in the show, we did not put them there and do not receive money from them. At this time, our sponsors are Logical Elegance and listeners like you.